Welcome my dear student in our math program for secondary 3. Dear student, today we are taking new lesson in calculus differentiation. What about calculus differentiation? We have revision or general revision about calculus and differentiation with integration. Revision about calculus. Number 1, find integration of x plus 1 over bracket contains 2x plus 1 for all power 5 dx. Dear student, look at the solution. We have problem. What is the problem? 2x plus 1 for all power 5 in denominator. We multiply x by 2 and divided by 2. After that, the fraction becomes 1 over 2 multiply fraction, the first 2x plus 1 inside bracket plus 1 over 2x plus 1 for all power 5 dx. Why? Because integration has no division of integration. We divided numerator and denominator into two functions. We make integration about two functions. The first becomes 1 over 2 integration 2x plus 1 over 2x plus 1 for all power 5 dx plus integration or half multiply integration 1 over 2x plus 1 for all power 5 dx. Then integration of 2x plus 1 for all power negative 4 multiply half plus half multiply integration of bracket contains 2x plus 1 for all power negative 5 dx. Answer is quarter multiply 2x plus 1 for all power negative 3 over negative 3 plus quarter multiply 2x plus 1 for all power negative 4 over negative 3 plus c. Answer is negative 1 over 12 multiply 2x plus 1 for all power 3 negative 1 over 16 multiply 2x plus 1 for all power 4 plus c. Now we are translate to another example. Find integration of bracket contains 6 squared x over 2 minus cosine 3x dx. Remember, dear student, we have integration about bracket. Bracket contains 6 squared x over 2 minus cosine 3x dx. Dear student, look at the solution. 6 squared 10x over 2. Then integration of 6 squared to 10x over 2 minus third sine 3x plus c. For the function f, where this example very important, f of x equals x power 3 minus 6x squared plus 9x plus 2. This function, the local maximum has local maximum and local minimum values, as well as inflection point if this exists. And finally, sketch the graph of this function. It's a very important example. Look at the solution. At the first, f of x, dear student, x power 3 minus 6x squared plus 9x plus 2. What is the differentiation? Yes, 3x power 2 minus 12x plus 9. F dash x equals 0 by factorization. Answer is x equals 3, x equals 1. We find f of 3 equals 2, then 3, 2 belongs to the curve. F of 1 equals 6. About substitution 1 in the function equals 6, then 1, 6 belongs also to the curve. We have 2 points. The first point 3, 2, Second point 16. Look at f double dash x. We make differentiation again. 6x negative 12. What is the value of f double dash at x equal 3? By substitution about x equal 3, then f double dash 3 equals 6. What you mean 6 more than 0? What you mean f double dash 3 more than 0? In this case, has maximum or minimum? Look at the student. F double dash 1, also by substitution about x equals 1, answering negative 6 smaller than 0. What you mean? Then, the point 32 is local minimum. The local minimum value equals 2. When substitution about 3, local value minimum equals 2. Also, the point 16 is local maximum. Maximum value equals 6. When substitution about x equals 1, the function equal or local maximum value equals 6. Look at the graph, dear student. We have more points. The curve of the function convex downward for all x bigger than 2 and upward when x smaller than 2. F of 2, dear student, equals 4. 2, 4 belongs to the curve. 0, 2 belongs to the curve. Look at another example. If the function f, where f of x equals 2 branches, the first branch x squared plus 2x negative 2a when x more than or equal 0. Second branch 8 plus sine px when x smaller than 0 is differentiable at x equals 0. What is the required? Find the value of the constant a and b. Solution. Dear student, look at the function is differentiable at x equals 0. What you mean function is differentiable at x equals 0? Dear student, this function is continuous also at x equals 0. The function is continuous at x equals 0. Therefore, we have f0 plus equal f of 0 minus. By substitution, limit when x tends to 0 positive, x squared plus 2x plus 2a equals limit when x tends to 0 negative, 8 sine px. By substitution about x equals 0 in left hand side and x equals 0 right hand side, what you deduce? Excellent student. 2a equals 8 plus sine 0 equals 2a equal 8. In this case, a equals 4. After that, f0 plus equal f of 0 minus. Then at x equals 0, differentiation to x plus 2. What is the differentiation of the first left hand side? F dash 0 plus equal f dash 0 minus. Then 2x plus 2 equal b cosine bx. 2 equal b cosine 0. Therefore, b equals 2. This example is very important. Function is differentiability at x equals 0. Find the value of a and b. What you do? In this example, function is differentiable at x equals 0. Then the function is continuous at x equals 0. What you mean? F of x is continuous at x equals 0. Limit when x tends to 0 positive equals limit when x tends to 0 negative. By substitution about left hand side, right hand side, we find the value of a equals 2. After that, when we find the value of b, we prove that the function is differentiability at x equals 0. Then f dash 0, left hand side, equal f dash 0 negative. We find limit when x tends to 0 positive equal limit when x tends to 0 negative in continuous. But in differentiability, we find f dash at x equals 0 positive equal f dash at x equals 0 negative. Also find the value of v equals 2. This example is very, very important. Now we are translate to another one. Find the equation of the tangent to the curve y equal x sine x, x cosine x minus sine x. Find the equation of the tangent to the curve y equals x cosine x minus sine x at point pi over 2 and negative 1. Solution. At the first, we find dy over dx equals 1 multiply cosine x plus negative sine x multiply x negative cosine x. The final answer, negative x sine x, is the slope of the tangent. dy over dx becomes negative x sine x. At point pi over 2, negative 1, substitution about x pi over 2, the slope of the tangent to the curve, negative y over 2 sine pi over 2 equals negative y over 2. Why? Because sine pi over 2 equals sine 90. Sine 90 means sine 90 equals 1. Then the slope of the tangent equals negative y over 2. After that, equation of the tangent at point pi over 2 and negative 1 becomes y negative negative 1 equals slope negative y over 2 at multiply x negative y over 2. Therefore, y equals pi over 2 multiply pi over 2 minus x negative 1. We translate to important example. Determine the absolute maximum and the absolute minimum value of the function f where x over x minus 1 in interval closed interval 2, 4. Dear student, determine the absolute maximum and the absolute minimum value of the function. What is the function? X over x minus 1. What is the interval? Closed to 4. Solution. As a first, we find the value of f dash x. We have division of two functions. Denominator power 2, denominator multiply differentiation of numerator, negative, numerator multiply differentiation of denominator. Then f dash x equals x minus 1 for all power 2 in denominator, then in numerator 1 multiply x minus 1, negative x times 1, then f dash x becomes negative 1 over bracket contains x minus 1 for all power 2. Remember, this function not equal 0. If y when x equals 1, f dash x is undefined when x equals 1. Why? When x equals 1 in denominator becomes 0. Negative 1 over 0 has no meaning or undefined. X, in this case, 1 doesn't belong to and 4 closed interval. Then f dash is undefined at x equals 1 and 1 doesn't belong to and 4. We find the function doesn't have critical point. Why? Because 1 doesn't belong to and 4. By substitution in the function by the two ends of interval 2, 4, we find f of 2 equals 2, then f of 4 also equal 4 over 3. We have absolute maximum at value equals 2 or absolute minimum at x equals 4 equals 4 over 3. We determine absolute maximum 2, absolute minimum 4 over 3. absolute maximum at x equal 2, absolute minimum at x equals 4. Another example. This example is very important. If we have x, y equals 2, we prove that x power 2 d2y over dx squared plus 3x dy over dx plus y equals 0. Remember, dear student, we have xy equals 2, function xy equals 2. What do you deduce? We have x times y. We find, or we must prove, x squared d2y over dx squared plus 3x dy over dx plus y equals 0. This example is very important. We have xy. We want dy over dx. After that, d2y over dx squared. By substitution about left hand side, answer is 0. Look at the solution. xy equals 2. What you mean xy equal to? Dear student, y equal 2 over x, or 2x power negative 1. At the first, we find dy over dx. dy over dx equals negative 2x for all power negative 2. Why? dy over dx, negative 1 times 2 negative 2, and decrease 1 x power negative 2, or negative 2 over x power 2. Also, we find this d2y over dx squared. d2y over dx squared equals what? Negative 2 times negative 2 equals 4x power negative 3. Answer is 4x power negative 3, or equals 4 over x power 3. Remember, dear student, we have dy over dx equals negative 2 over x squared. Also, we have d2y over dx squared equal 4 over x power 3. Therefore, left hand side becomes x squared d2y over dx squared plus 3x dy over dx plus y equals 0. By substitution about d2y over dx squared and dy over dx left hand side, we find left hand side equals 0. X squared multiply 4 over x power 3 plus 3x times negative 2 over x plus 2 over x equals 0. Therefore, 4 over x minus 6 over x plus 2 over x, look at denominator x, 4 minus 6 equal negative 2 plus 2, answer equals 0. Then we prove that left hand side equals 0. Look at important example. The volume of a sphere is V centimeter 3. Its radius is R centimeter and surface area is A centimeter 2. Prove that dA over dt over for all power 2 equals 16 pi times dV over dt times dr over dt. Then calculate the rate of increase of volume at instant where R is increasing at a rate of 1 over 4 centimeter per second. And find the area, and in this case, in this instant, A is increasing, or dA by dt, at rate 2 pi centimeter 2 per second. Remember, 1 over 4 means increasing of R respect to the time. Then dr over dt equals what? 1 over 4. Also, dA over dt equals 2 pi. Dear student, this problem is very important. Volume of a sphere, area of a sphere. What you mean volume of a sphere? Volume of a sphere, 4 over 3 by r power 3. What you mean? Area of sphere 4 by r power 2. In this case, we find relation between volume and the area. Relation between volume and the area, we must find the volume of a sphere by using 4 over 3 by r power 3. After that, we find dv by dt, or we find differentiation volume about the time t. Also, we find area of the sphere by using area equals 4 by r power 2. After that, find dA over dt. Why? Because dA over dt means increasing area respect to the time. Dear student, look at the solution. Since volume equals 4 over 3 by r power 3, volume of what? Volume of sphere. Then dv by dt, we find volume respect to time t. Remember, pi is constant, therefore equals 4 by r power 2 dr by dt. This equation's number 1. Remember, dear student, we have volume equals 4 over 3 by r power 3. What is the differentiation respect to the time? dv by dt, 4 over 3 times 3 equals 4 by r for all power 2 times dr by dt. Area equal 4 pi r power 2. Also, we find dA over dt equals 8 pi r times dr by dt. dA over dt for all power 2, 64 pi r dr by dt, or for all power 2. Then dA over dt for all power 2 equals what? 16 pi times bracket contains 4 pi r power 2 dr by dt times dr by dt. This equation number 2. Look at equation 1 and 2. From 1 and 2, we find dA over dt for all power 2 equals 16 by dv over dt multiply dr over dt. Therefore, this relation between area and volume of sphere dA over dt for all power 2 equals 16 by dv over dt times dr over dt. Since dr over dt from the given equal 1 over 4, also dA over dt equals 2 pi. About substitution, then 2a 2 pi dA over 3 for all power 2 equals 16 pi times dv over dt times quarter, also dr over dt, remember, equal 1 over 4 equals what? Equal dv over dt equal by centimeter 3. This is the required. Now we are translate to another example. Find the slope of the tangent of the curve x power 3 plus x2y minus 3xy squared plus y power 3 equals 4 at point -1, 1. Solution. Since we have equation, left hand side x power 3 plus x squared y minus 3xy squared plus y power 3, the right hand side equals 4. We find differentiation respect to x. Then left hand side becomes 3x x power 2 times x power 2 dy over dx plus y times 2x negative 3 times bracket contains x plus 2y times 2y dy over dx plus y power 2 times 1 plus 3y squared dy over dx equals 0. Therefore, when at x equal -1, y equal 1, by substitution to find the value of dy over dx, look at the equation is 3 times 1 plus bracket contains dy over dx plus 1 times 2 times -1 inside bracket minus 3 multiply negative 1 times 2 dy over dx plus 1 plus 3 dy over dx equals 0 to find the value of dy by dx. Therefore, look at 10 dy over dx negative 2 equals 0. Then 10 dy over dx equals 2. dy over dx equals 2 over 10 equals what? 1 over 5. Therefore, the slope of the tangent of the curve equals 1 over 5 at negative 1, 1. Now we are translate to another example. Find the equation of each of the tangent and the normal of the curve y equal 10x at x equal pi over 4. Find the equation of each tangent and the normal. Remember, dear student, we have equation of the tangent and equation of the normal. Dear student, equation of the tangent equals what? Y minus y1 equals m multiply x minus x1. What is the equation of the normal? This equation of the normal, y minus y1 equals negative 1 over m multiply x minus x1. In this equation, we find the equation of the tangent and the find equation of the normal. Look at the solution. Dear student, look at the solution. When y equals 10x, we have x equals pi over 4, y equals 10 pi over 4. What is the 10 pi over 4? 10, 45 equals 1. This point pi over 4 and negative 1. Since y equal 10x, dy over dx 6 square x. Therefore, at x equal pi over 4, dy over dx 6 square x 6 square pi over 4 equals 2. Slope equals 2. M equals 2. What is the equation of the tangent? Y minus y1 equals m multiply x minus x1. Substitution about y1, x1 and m. x1 pi over 4, y1 1 and m equals 2. Therefore, y negative 1 equals 2x minus pi over 2. Then 2y minus y, 2x minus y plus 1 negative pi over 2 equals 0. Therefore, 2x minus y plus 1 minus pi equals 22 over 7 divided 2, negative 11 over 7. Then 2x minus y plus 1, negative 11 over 7 equals 0. Pi multiplied by 7. Therefore, equation becomes 14x minus 7y plus 7 minus 11, or 14x minus 7y minus 4 equals 0. This equation of tangent. But equation of normal, y minus y1 equal negative 1 over m x plus minus x1. Then y minus y1 equals negative 1 over 2 times 2 x minus pi over 4 inside bracket, 2y minus 2 equals negative x plus pi over 4. Then x plus 2y minus 2 negative pi over 4 equals 0 times 4 left hand side, right hand side. Answer is 4x minus plus 8y minus 8 negative y equals 0. Therefore, by substitution about pi 22 over 7, then multiply by 7 in each term. Equation becomes 28x plus 56y negative 56 negative 22 equals 0. Answer is 28x plus 56y negative 78 equals 0 divisible by 2. Answer is 14x positive 28y negative 39 equals 0. This equation of the normal of the curve. Now we are translate to end of the revision about calculus differentiation. I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.